Here we are for the next section of physics of motion. We have covered all the topics of this chapter, and the last chapter is uniform circular motion, as you can see here. Okay, so what is a uniform circular motion? I have given you a little bit hint in the last video, but now I will be giving a little bit more detailed about the topic. So, what is a uniform circular motion? Now, you know that whenever the velocity of an object changes with time, we say that the object is accelerating, right? So, the change in this velocity could be due to the change of its magnitude either or direction. So, you know that velocity is a speed with direction. Okay, so velocity has two components. First is the magnitude, which we call the speed, and another is the direction. So when I say that the velocity of an object is changing, so either I am talking about its magnitude और its डायरेक्शन और बोथ. ओके, सो अगर तीनों में से कुछ भी होता है, या तो मैग्नीट्यूड चेंज होता है या डायरेक्शन चेंज होती है ऑब्जेक्ट की, या दोनों ही चेंज होते हैं, तब हम बोलते हैं that an object is accelerating. There is some acceleration. Okay, so what is a uniform circular motion? So can you think of any example where the speed or the magnitude of the velocity remains constant but the direction changes? Okay, such type of motion can be called as a accelerated motion, and uniform circular motion is such type of motion. So let's see some diagrams here. The first one is a rectangular track. So for example, a person is walking on a rectangular track or running. Okay, so uh, from A to B, the whole path he runs with a constant speed, means the magnitude of the velocity is constant, the speed is not changing. But as soon as the track ends here, he has to change the direction, right? So to change the direction at this edge, he has to move to the another track, which is BC, right? So at this point, it when the object changes the direction, the object is said to be accelerated, means the velocity of an object is changed because at this point the direction is changed. Then when it moves along the line BC, it travels with constant speed, no direction change and no change in the velocity, means no change in the speed. Now as soon as it gets at a point C, okay, it changes its direction to CD, and at this point C, the object is said to be accelerated because the direction is changed. It was this before and now it is this. So at this point the direction is changing. Let's see one more example. This is a hexagonal track. Okay, so you can see here, okay, in this diagram there are four sides, right? 1, 2, 3 and 4. So if there are four tracks or four lines, the object has to change the direction four times. 1, 2 and 3, 4. Okay, so four times he's changing the direction. Let's come to an hexagonal track. In this case, there are six sides, as you can see. So if a person is walking on such type of a track or an object is moving, he has to change its direction six times. So you can see in these diagrams that as much as the sides or the tracks or the path increases, the number of directions is also increasing, right? So let's see this octagonal shaped track. In this case, there are eight sides. So a person walking on this, walking on a path will have a constant speed, but as soon as it changes the path at each and every corner, the velocity of an object changes because the direction is changing. Okay, so he has to change its direction eight times. Now, why am I showing you these pictures? Because we have to come to a circular motion. Okay, and how do you get a circular motion? Let's say there are four sides here, then you have increased the number of sides 4 to 6, then to 8. So what is happening, that as soon as you are increasing the number of sides also, the number of directions is also increasing. Okay, the person has to change its direction multiple times. So as soon as if I keep on increasing the sides of any path like this, it will ultimately turn into a circle, a smooth circle. Okay, so as you can see that in all such diagram, a person has to change its direction, right? Otherwise he will not be able to move on these paths. So from these diagrams, we see that if I increase the number of sides, I get a circle. Okay, so if a person is moving on a circle, as you can see, there is no edge, but still, if a person is moving on a circular path, okay, the direction of the person, it is changing its direction at each and every point. All right, but like you can see here, uh, at in the line AB, the person is changing the direction at A and B only, not in this path, right? Because there is no change in direction here. But in case of the circular motion, each and every point act as a change in velocity, because हर एक पॉइंट पे जब भी ऑब्जेक्ट मूव करेगा, हर एक पॉइंट पे उसकी वेलोसिटी चेंज हो रही है। क्यों? क्योंकि उसकी डायरेक्शन चेंज हो रही है। ऑलराइट, सो दिस इज अ सर्कुलर ट्रैक, and since I have told you that if a velocity changes, we say that an object is accelerating. Okay, so the change in velocity can be due to its magnitude or its direction. So in all these cases, the direction is changing, so hence I say that the velocity is changing. So if the velocity is changing, then the object is said to be accelerated. So this is a uniform circular motion, and a uniform circular motion is an accelerated motion because the velocity of an object keeps changing in a uniform circular motion because its direction keeps changing. All right, so these were few examples of uniform circular motion, and it's all been explained here. This is an NCRT PDF. All right, okay, so as we are dealing with the chapter motion, and we are studying about speed, velocity, and everything. So in a circular motion, how can I find the velocity of an object? I'm saying the velocity of an object changes, so how can I find it? Okay, so as you know that velocity is defined as displacement over time, right? Or the speed is distance over time. So in the circular path, if an object starts from this point and moves the whole path, okay, covers the whole circumference and comes back to the initial point, so it has traveled this much distance, which is 2 pi r. Okay, the distance traveled is the circumference of the circle, which is 2 pi r. So we know that the circumference of a circle of a radius r is given by 2 pi r. So if an athlete takes t seconds to go once around a circular path, अगर उसे यहाँ से यहाँ जाने में time t लग रहा है, then the speed, we can find the speed of an object, which is distance over time, 2 pi r upon t. Okay, so when an object moves in a circular path with a uniform speed क्यों बोल रहे हैं? क्योंकि speed constant है, सिर्फ direction change हो रही है. So how will you say that what is a uniform circular motion? So whenever an object moves in a circular path with a uniform speed, its motion is called as a uniform circular motion. All right, such type of motion is an example of an accelerated motion also, because in uniform motion, the velocity is changing although the speed is constant. All right, so this was the last topic of this chapter, which is uniform circular motion. Here also you can see a person where it's an activity you can see and do it at home also. So it's a person with a stone or some ball, and it has hang that ball with a thread. And what he does is he just swirls the stone in the air like this. Now, because he has started the motion, the ball moves in a circular path. Okay, right? So you can see here that this is because once the stone is released, it continues to move along the direction it has been moving at that instant. So हर एक point पे जिस direction में वो पीछे से आ रहा है, उसी direction को वो continue करेगा. Alright, so this shows that direction of the motion changed at every point when the stone was moving along a circular path. Then only the object is able to move in a circular path because the direction is changing at each and every point. Otherwise, it has just gone out of the way and not have formed a circular path. Alright, so there are so many examples such as motion of the moon around the earth, the motion of the earth around the sun. All these motions are example of a uniform circular motion. All right, so this was the end of the chapter. uh, so in this chapter we have studied some basic terms such as distance, displacement, speed, velocity, acceleration, their units, SI units, their symbols, their formulas. We have studied about uniform and non-uniform motion, uniform circular motion as well. And also, most importantly, we have studied three equations of motion that relate these quantities. And we have seen that how can we derive them graphically. All right. So these are the chapter has ended. and you all will practice the NCRT in-text questions which are given inside this chapter. Okay, and we will discuss them whenever we can. They are very easy and you can do it. So